Now this week, guys, we're doing the theory for week 2, and week 2 is basically this. Now, you guys, last week we had a look at linear. We looked at sketching lines. You can see there that we jumped from different places in the textbook. Essentially, this last part here, if you could more or less get a line, you could rearrange an equation, sketch a line in a number of ways by either finding the intercepts or using the gradient and the y-intercept. Either way, we want you to be able to sketch lines. That was week 1. Okay? Now, the stuff this week, though, expanding binomial products. In other words, just expanding using distributive law. That's pretty much all that is. And then once we're expanding, we're looking at basic factorization. In other words, we're looking for highest common factors. If we expand, it's factorizing is going in reverse. It's going the other way. All right? And then solving equations, what we call using the null factor law. Now, the whole point of all of this is because when we go to sketching a quadratic, now, for starters, if I was to go into my graph and I was to go to the home screen and to the graph, and if I was to put in the graph of x squared plus 6, okay, and then I was to zoom out. Now, we're going to get into using this calculator later. Okay, zoom out. Now, let's think about it. What does to find the y-intercept, what do we have to let x equal? 0. Okay, so can you tell me where would be the y-intercept for this graph here? Where would be the y-intercept? 6, because if I let x equal 0, what does y equal? Okay, what about if I was to solve for the x-intercepts? What would I have to let y equal? 0. Now, can you tell me, is there any x-intercepts in this particular graph here? No, and I'll show you why. Now, if I was to go here, and I was to go to, I'm just going to get some blank sheet of paper, and I've basically got this. I've got the graph of y equals x squared plus 6, right? Let's just say it looks like that, and this point here, 0, 6 is my y-intercept. Now, why doesn't it have an x-intercept? We've got to ask ourselves. Well, for starters, I've got the graph of y equals x squared plus 6. This is what we call a quadratic because this power is 2. Now, if I wanted to go ahead and I let what equals 0 for the x-intercept? Y. Okay. 0 equals x squared plus 6. What do I do to both sides to get that? Yep. Minus 6. Okay. I've got x squared equals minus 6. Now, what might be wrong with this statement? If I went to go into a calculator and I did the square root of minus 6, what happens? Can we do the square root of negative number? No, it doesn't exist. So therefore, there's actually no solutions. But what happens if I was to change my graph to something else? What happens if I was to change my graph to, I don't know, let's just say x squared plus 5x plus 6, for example. Now, can someone tell me, if of this graph here, x squared plus 5x plus 6, what's going to be the y-intercept? 6, because x equals 0, doesn't it? Yeah. Y equals 6. All right, so we know that. All right, and I could actually, later on, I can go analyse graph and I can look at the intersections and all sorts of things. We'll get to that later. But the whole point is there x-intercepts here? Yes. Yes, there is. Yeah. Now, I'm going to show you something. Now, our calculator can go analyse graph 0, and I can basically pick a lower and a left bound, and I'm going to say that, all right, there you go. We actually have an x-intercept at where? What coordinate is there an x-intercept? -3. -3. Okay, now that's one intercept. Let's have a look at the other one. Let's go to 0. I'm going to pick left of this intercept, and what does that one say? Well, I'm going to have to drag that. But what does it say? -2. Yeah, I'm going to drag that over there. So, okay. Now, these intercepts we can find using a calculator, but we can also find by hand, and that's by what we call factorizing. So, but before we do get to, so I want to give you the big picture today. This is why we're doing it. We're not just doing it for no reason. We're doing it because we're going to eventually be having quadratics, and we're going to have to find both the x-intercepts, which is the hard part, and the y-intercept. As we said before, let x equals 0. That's the easy part. Okay? So when it says down here that we're going to expand, that is basic algebra, guys. And then factorizing is going the other way, and the reason why we factorize is to find and to solve equations, which is lesson 3. Now it looks like a lot, but I can tell you we can go through that stuff in 25 minutes, half an hour, and we can at least practice it. And once we practice it, you're going to start getting the hang of it. So let's get into expanding binomial products. First of all, what law is it where we're expanding brackets?
Distributive law.
Distributive law. Thank you. Distributive law. Now, it's important that you have to multiply each thing in the bracket. So if I have 2 brackets, then I'm going to if I had 2 brackets, for example, 1 thing, 2 things, 1 thing, 2 things, let's say added together, I'm actually going to get 4 expressions. Now, let's expand and simplify these then. 5 times x is what? 5x. Good. And what's the next expression? That's one expression. What's the next one? Minus 20. That's right, minus 20. Now, how many expressions before simplifying am I going to get for this next one? We've got 1, 2, 3, 4 expressions, and then we collect like terms, which we would have done in year 7 and 8, and then when we collect those like terms we can simplify. So let's do that. Now y times y, now guys might be thinking y times y, well think about it, y to the power of 1 times y to the power of 1. This is why we did indices. Y squared, absolutely. So my first expression is y squared. Now then I have to apply this one, y times 9. Plus 9y, good. Now then we have to apply this guy over here, y squared, okay, and then minus 4y. Okay, now what I need to do is I need to collect like terms, and I'm going to collect like terms by adding only the things which are like. I've got y squareds here and a y squared there. How many y squareds do I have? How many y squareds do I have? I have 2 y squareds. Y squared plus a y squared is 2 y squareds. And I've got 4 yachts, and I've subtracted 4 yachts from 9 yachts. How many yachts do I have? 5 yachts. Okay. Now, let's look at this next one. I'm going to pause this video and I'm going to get these whiteboards out. I want to see you guys expand and simplify these 2 expressions. Now, I know you can get it on your sheet of paper in a moment, but I'm going to hand these whiteboards out and see how you go. So guys, with this one, I saw most of you got it right the first time. But at the same time, yes, we've got 1, 2, 3, 4 expressions. What I did see a lot of, though, is I saw this right a lot, 2x plus 10. I then saw the minus 3x right most of the time, but remember that I'm applying that minus 3 to positive 9. So some of you actually had positive 27 or something along those lines. That's actually negative 27. Now I'm collecting like terms. 2x subtract 3x is negative x. And I'm subtracting 27 from 10. That gives me negative 17. So this should be your simplified answer. Now, the next thing is that we've got the same thing. We've got 4 expressions, but what I saw a lot of, I saw this correct for most of you, 3x minus 6. But then a number of you, minus x, I actually saw that a fair bit, but a lot of the time, this one was the one that got you. Negative, if you think about it, it's the same as negative 1 out the front, negative 1 times negative 5. 2 negatives multiplied by each other, not added together, multiplied by each other is a positive result. So we've got positive 5. Now we've got to simplify. I'm subtracting x from 3x. So I've got 2x, and if I'm adding 5 to negative 6, think about the number line. If I've got negative 6, I'm going 5 towards 0, but I've still got 1 left, so it's 2x minus 1. Now, I know that you guys, a few of you, only probably about 4 or 5, made that silly little slip up. Let's see how we're going this time. Now, I want you to expand these binomial products. Now, at the end of the day, let's think about it. Let's think about this. If I had the graph y equals x squared plus x minus 20. All right? What would be the y-intercept?
20. Minus 20, mate.
Okay, now can I just say, if this factorised to this, if it factorised, if this expression here, this is why we do factorising, if that factorised to that, how could that make our life easier when finding the y-intercept? Or sorry, the x-intercept?
Yeah.
Let's think about it. Let's think about x squared plus x minus 20. I'm going to just show you this. X squared, if I was to go, I want to do a new graph, so I'm going to go to a new document, and don't want to save that. And if I wanted to go to add graphs, now I'm going to put in the graph of x squared plus x minus 20. And what do you notice? What do you notice? For start, what's the y-intercept? What would be the y-intercept of x squared plus x minus 20? Negative 20. Okay. And can you see that there's two intercepts there? Now, I'm going to tell you this. Let's have a look at where those intercepts are for the time being. You can see that one's negative and one's positive. If I go over here, I'm going to tell you that this expression x squared plus x minus 20 factorizes to this. Because if we expand that out, now expand it out. X times x is x squared. Okay, x times x is x squared. All right, x times minus 4 is minus 4x. 5 times x, 5x. And 5 times minus 4, minus 20. Okay, I then collect like terms. What do I do to these terms? If I add these together, what do I get?
X.
X. So I've got x squared plus x minus 20. Can you see that this expression here and this expression here are exactly the same? It's just that I've expanded that one out to get this. Does that make sense? Now, if you think about it, where do you think, does anyone want to take a guess at where the x-intercepts would be for y equals x squared plus x minus 20? Does anyone want to take a guess? What do we let equal 0? We let y to find the x-intercept. So if that expression is the same as this, x plus 5, x minus 4, and that's equal to y, but y equals what at the x-intercept? 0. How can that statement be true? I'm just going to get you to think about that. How can that statement that we've just wrote, 0 is equal to this times this, how can that possibly be true? There's two cases. So we've had our little discussion. There's two cases of this being 0. That is, case 1, x plus 5 could be equal to 0, or what's the other one? X minus 4 is equal to 0. So therefore, what would x have to be in this case for this to be 0? 5? Negative 5? Or x could be positive 4. Now let me show you some magic. If I go to menu and I go to analyze graph and I want to go to 0, what did we say was the negative result? Negative. Oh, look at that. Okay. Oops. You can see negative 5. And what did we say that the x-intercept would be? The positive? 4. Menu. Analyze graph. 0. In other words, we're finding when y equals 0. And you can see there that we've got x equals 4. That's why we're doing it. All right? Now, so you can see there that that's why we're factorising. But for the time being, we're going to continue to expand. Can I just pause this, guys, and can I get you on your folders? I want you to expand these two, please. I'm just going to pause that here. Resume this now. So first of all, what a few students did, some students did this, they applied this and then this. There's always going to be 4 expressions. 2 things times 2 things is 4 things. Okay? So y times y is y squared, and yes, 3 times 9 is 27, but that's only 2 expressions, 1, 2. There's actually 4. We've got to do this, 3 times y, which is plus 3y, and 9 times y, which is 9y. Now what we do is we collect like terms. Now there's only one y squared, and there's only one constant. There's only one constant. So what we're doing is we're adding our like terms, which are these. So our answer is y squared plus 12y plus 27. Now that one's pretty straightforward compared to this one, but I was pretty impressed to see most of you give this a fair go. 3x times 2x. Now think about it. If I add x times x, what does that equal?
2x. I mean
x squared. So 3 times 2 is 6. So it's 6x squared. Now we've done that one. So 3 times 2 is 6. X times x is x squared. The next one is, I'm going to go over here and do this one. 3x times negative 2 is what, boys? Negative 6x. A lot of people drop that x for some reason. It still exists. 6 times 2x is 12x. And 6 times minus 2 is our last expression, which is our fourth expression, which is minus 12. Now, there's only 2 things that we can collect like terms with. These 2. Now, I'm either subtracting 6x from 12x would give me 6x, or I'm adding 12x to minus 6x. Either way, it's still going to give me positive 6x. And, of course, that negative 12 doesn't go anywhere. Now, forget about these perfect squares. What I'm going to be looking at now is factorizing, looking at factorizing. Now, we discussed why we factorize in the context of quadratics. What I'd like you guys to do is this. The first one is pretty straightforward. The highest common factor of 8 and 12 is what? 4. 4 goes into 12 3 times. And 4 goes into 8 2 times. Okay? My highest common factor of 8 and 12 is 4. This is the highest common factor. Now, we've done the first one for you. What I'd like you guys to do now is have a bit of a think about what is your highest common factor for B and C. I'll give you a few minutes to do now and go through this. So as I've just said, guys, in order to factorize, we need to learn the basics of finding the highest common factor. Now, the problem is, though, that we can have highest common factors with pronumerals and not just numbers. The first one, though, we did say that if I had 2 expressions, 8 and 12, I could actually put 4 out the front, and I could then say 4 times 2 is 8, and if you like, 4 plus 4 times 3 is 12. Okay, I've just factorised those 2, if I had those 2 expressions. That's the same thing. If I had 8 plus 12, then if you think about it, 4 times 2 is 8, 3 times 4 is 12, 12 plus 8 is 20, and so is 12 plus 8 there. Okay, they're exactly the same thing. We've just factorised them. Now, the same thing, if I had 100x plus 75, 100x plus 75, well, I'm looking for a number and pronumeral which goes into both. Now, they don't share an x, so we cannot bring out x as a common factor. But the number, the highest common factor, you might think 5 at first. Well, no, in actual fact, it's 25. But you could actually sometimes do that in 2 steps. So I take out 25. Now, if I was to expand these brackets out, I need to get this same result again. 25 times what is 100x? 4x, and 25 times what is 75? 3. So I've now factorised that. For the time being, it doesn't make much sense, but we'll make some a bit more sense later. Now, this time, what is the highest common factor of 2 and 10? Let's just worry about that first. What's the number which goes into 2 and both 10? 2. 5 doesn't go into 2. So we take out 2. Now, do they both share anything else? They both share an x. Okay, they don't share an x squared or an x cubed, just an x. So therefore, I've got to, if I was to expand this bracket out, how would I get exactly the same result? 2x times what gives me 2x cubed? X squared. Very good. So if I was to expand, you can always check your answer to these. Because you expand it back out, you're going to get exactly the same result. The last one is 2x times what is 10x? 5. Okay. So therefore, there you go, we've factorised 1, 2, and of course, we've found the highest common factor. So, to summarise so far, we've expanded. Expanding's going one way. We're going from this to this. In other words, we're reverse factorising. And when we factorise, we're going from this to this. In other words, we're including those brackets. And we do it so we can solve equations. Now, what I'd like you to do, or actually I've been through this, for maybe a few students have gone through this already. What I'd like is for you to factorise each of these expressions. In other words, you've got a number, could be a pronumeral out the front like x or a, and then you've got a brackets and something else. So I'm just going to pause it for the time being. For those students that have done all of these already, move on and try the next one. So just quickly, guys, look, this one was done very well from what I could see. The highest number that goes into both is 3, x plus 3. Fairly straightforward. However, with this one, the highest number, the highest common factor, yes, the number is 5, but they both share an a. And remember that 5a times something is going to give me 10a, so that has to be 2. Minus 3a squared, because a squared times a is a cubed. Now, if you think about it, this is why we learn index laws. Look at this, a times a squared. What do I do to the powers? I add the powers. Those that struggle with index laws are, for the time being, going to have a little bit of problems here, so we need to fix those up. Now, remember that you can always check your answer because you can expand back again. If I expanded those two expressions and I don't get my original thing, 5a times 2 is 10a, and that is minus 15a cubed, and then you ask yourself, is that? Then if they aren't equal, then clearly you haven't factorised correctly. Now over here, some of you took out 2 as a common factor, but the highest common factor is 4, but they both share what? A y. So 4y times something is going to give me 4y, that's a 1, and 4y times something is going to give me 16xy, so that's 4, and what am I left with? X. Oops, I'm just going to have to pause that because I lost my... Alright, that didn't take long. Now, for this last one, what do all these expressions share? They share a what? They share a 5, I guess highest common factor of 5, but they also share an x, that's right. So 5x times something is 5x squared, that's going to be x plus 5 what? X squared. X squared minus 2. Excellent. Very good. You guys are nailing this stuff. Now look, I did give you this as a bit of an extra. This is what we call factorising by grouping. And this is something that I don't expect, you're not going to be assessed on, but I want to just point this out. If I was to break these down, let's have a look at the first 2 terms. What I want you to do, we'll have a bit of a look at it anyway. Let's break down the first 2 terms and I want you to factorise that. Then I want you to factorise these 2 terms. I want you to do the same with this and this. Have a go at it, please. This is as hard as it gets in terms of factorising. This quick. Now, I just want to make you aware of whenever you see 4 expressions, sometimes the hint is that we can actually factorise by grouping. Now, I've given you the hint that we're going to look at the first 2 terms and the last 2 terms. It's not always the case. But what you notice there is that if I factorise this, my highest common factor of both of those is x. Now, what goes in the brackets then? X times what is x squared? X and plus 2. Okay, now what we then do is what's the highest common factor of ax and 2a? What do they both share? Plus a. Good. And I would have x plus 2. All right, now this is where the magic happens. What do they both share? They both share a x plus 2. Now, that is actually the highest common factor is actually x plus 2. Now, think about it. We've got an x plus 2, we've got an a times an x plus 2, and an x times an x plus 2. So, therefore, I've actually factorised by grouping x plus a. Now, we've done the first one, the same thing applies. Let's do it again. What's the highest common factor of xa and 3a? A. So I take a out the front, which means I've got x plus 3. What's the highest common factor of this one?
5.
Now, if I took out a 5, if I took it, yeah, I'm going to take a negative 5 out the front. Negative 5, and look, x plus 3. Now you can see that the highest common factor of those is actually x plus 3. So we've now done what we've called factorising, grabbing this term, a minus 5. Now, factorising by grouping, I've always found is one of the hardest things for students to recognise. But usually the hint is, if I ask you to factorise and there's 4 expressions, sometimes that's a bit of a hint. Now, the last thing I wanted to show you is why we're doing this. Now, when we're solving equations, we need to set, we're using what's called the null factor law. Null meaning 0. Now, if I have this expression, for example, I might have this expression here, y is equal to 2x squared minus 8x. Now, how do I find the X-Intercept? What do? Okay, so I make y equals 0. Okay, now, so I just want you to follow with me for the time being. So, what we do is we make y equals 0. So I'm going to replace it like this. 2x squared minus 8x. Now, how would I find the solution to that? What's the highest common factor of 2x squared and minus 8x? I've got an x and a 2. So I take out 2 as a common factor. 2x, what's in the brackets? X minus 4. Okay. Now, how could I solve this? This is where I said, how can this equal to 0? There's either two things. Either this equals 0, or what? This equals 0. So basically, to solve these equations, we need to first of all factorise, which we've just been through, and the second step is we need to use the null factor law. So therefore, if I wanted to solve this equation, we can either say that 2x equals 0, or what equals 0? No, x minus 4 is equal to 0. We're jumping the gun a little bit. So therefore, we've got two solutions. X equals 0 is this one. And what's the second one? X equals 4. Now, if I was to go sketch the graph of y equals 2x squared minus 8x, let's have a look what that looks like. I'm going to go, you know what? I'm going to tab across, or I'm going to go to Control G for a new graph. And I'm going to go to 2x, what was it? 2x squared. 2x squared. What was it? Minus 8x. What did we say our intercepts were?
0 and 4.
Okay, so maybe if I go to Analyze Graph 0, you can see there that it actually, on that green graph, it actually crosses the origin. And the second, so we're looking at graph 2, and the second intercept is where? At 4.
So in quadratic, there's always 2.
No, well, there can be 0, 1 or 2, but when we need to factorise and use the null factor law to find those intercepts. That's why we're doing it. Okay? Now, we don't need to do it yet, but we do need to factorise and use this null factor law.
So when it says BI doesn't equal 0, so 2...
Just quickly for this one, we are saying 2x squared minus 72, and that's equaling 0. Shh. Take out 2 as a common factor, and then I'm left with x squared minus 36. It's now factorised. Now, one thing that we need to get through. We'll get through to this later. We're going to be looking at factorising quadratic expressions. That comes after you go on holidays. All right. For the time being, we are just factorising and using null factor law. In particular, something like this. What's the highest common factor of 16x squared and 32x? 16x. So I take 16x out as a common factor. What's left inside here? X plus what? 2. All right. Now, this is null factor law. In order for this to be equaling 0, that is equal to 0, or that is equal to 0. Now, there's two cases. X can either be equal to 0, because 16x is 0, or x is what? X is negative 2. You have just solved an equation using null factor law. Right, guys, this is why we just did this. My graph was, what did we have? Didn't we say it was 16x squared plus 32x, yes? Now we factorised and used the null factor law. What did we find the two? X equals 0. Now have a look at this. If I zoom out a little bit, I've got a quadratic graph. And what do you notice? Where are the intercepts? Look at this. Negative 2. And the other one is at the origin. Hard to see. Shh. That's about it for me, guys. I'm going to stop this now. Thanks for your attention today. I know it's been a lot of concepts, but I want to make sure that come Friday, you've practiced this enough and at least you've seen it today. So now what's time's left? Half an hour-ish. Let's go and practice those.